Welcome back, everyone. Okay, so before the break, we were talking about gamut mapping. And I made sort of a fool of myself when I was trying to talk about this stuff, and I lost my place mid-sentence as if, it was, I don't know, pretty embarrassing. Okay, so I wrote down what I intend to say, and I'm going to read it to you. Okay, so we have two different types of gamut mapping. We have perceptual and colorimetric. Now, perceptual, as I said, is best for pictures because it maintains the full gamut. So there's no loss of colors that are outside of a smaller gamut that may have existed in a larger gamut. These full gradients still exist. They're just compressed, so to speak. Okay, so colorimetric, on the other hand, this is better used when you are trying to view something on your screen and you want the color that is supposed to be in this file to be represented very accurately by your screen. So whereas here, this would actually compress the colors from a wide gamut down to a smaller gamut, what we are doing is we are going to allow, in colorimetric, we're going to allow this region of the gamut to be displayed or rendered very, very accurately. So we use colorimetric typically when displaying images that have to have very precise color on screen. And so as you may recall, the gamut of a particular screen might be smaller than the gamut of say, Adobe RGB. And so what we might do typically then is use colorimetric to be able to display the colors that are on screen very accurately, and then just have the knowledge that there are other colors that might be clipped, or as we would see in, say, when we clip some highlights in a digital photograph, we might have additional colors here that just are not being represented by the screen. Okay, so we have this idea that we need to be able to profile our devices. So not only our cameras, which come kind of profiled by default, but also our monitors, and most importantly, our monitors. So many of you, if not all of you, have probably not profiled your monitor to have accurate color. And this is important to do to be able to accurately display all of the colors within this particular slide. So let's see. So just looking at it, and it's probably better seen elsewhere, one of the most obvious ways of seeing if your monitor is not properly profiled is to take a look at a grayscale, basically just a gray scale, to see if there are any color casts within it. So we know that this should be white, gray, darker gray, darker gray, darker gray, black. Well, this is black, but this is a very dark gray. And if you look at it and you see any color casts, and they're usually in the form of like a very slight amount of green or a very slight amount of magenta, and I think you can sort of see a slight green cast here, though my eyes might be playing tricks on me being this close. You know that your profiler, in this case the projector, is not properly profiled, and it is not displaying this color accurately on the screen. And so it's harder for us to notice when something is not properly profiled in these other colors, but it's very obvious to us, especially when it's grayscale. But this is representative of the problems that can exist throughout the color spectrum and all of the colors that you might have on screen. And so there's a variety of ways that we can profile our monitors. We could go to a store or to Amazon.com or just any photographic, or just any store where you can buy some photo stuff and buy a hardware profile. So what you can do with some of these hardware profiles is looks like a little hockey puck. You stick it onto your screen and it displays there's some software that this puck communicates, or rather the other way around. The software communicates with this puck and it displays a color on the screen. The puck is responsible for reading that color, and then it will know if that color is slightly off versus what it should be. And then the software then will go through a whole series of colors and scales from white to dark, for example, and it will create a profile for your monitor. You can then load that profile into your computer, and it's actually surprisingly easy. For those of us with Macs, and that's just because I happen to have one right here, you can just load up the system preferences, go into displays, and it's all under color. These are the profiles when it comes up. These are the profiles that I have for for this particular monitor. Now, I've been bad on this computer, but because I don't do any editing on this particular machine, I haven't actually profiled this, so I only have the default color LCD profile. If I had one of these hardware pucks and I was able to create a profile for this laptop, then I would be able to create one, load it here. You can see there's an open profile button. It makes it very easy. And all of the colors will just magically be rendered correctly, assuming you have a proper color management workflow. So assuming that you're using the correct color space, etc., for the image as it was displayed or as it was created. Okay, so there's that route. And usually the hardware profilers really range in price. You might see them somewhere from like $100 to way expensive, like $1,000 of worth of profiling. But those things can typically do stuff like profile projectors, profile printers, and be able to do it's very all-inclusive color management solution. So for those of us where we're just doing stuff on the web, then we probably don't need to spend all that much. And in fact, it is possible to do color profiling with software as well. So just using software and our eyeballs, we can try to create a color profile that closely matches what should be accurate. So you'll notice that very conveniently here, there's a calibrate button. So for those of us that have Macs, we have this calibrate button. For those of you on Windows, you will probably have to download some color calibration software. And there's freebies available online that color management websites recommend and be able to do some tests. And so what happens is you click on that, and I'm not going to actually do it because this takes, if you're being careful, this can take you a good amount of time. But you typically see something like this, and they're very cute. They put a little apple in the center, but usually it's just a square or something like that. And you have adjacent to it these lines that alternate from black to white. And the whole point of this is that you got to kind of squint your eyes at it a little bit and try to blend the color. And so what you want to do is adjust the brightness and the darkness of this center part. So as you can see, it's okay. It's not happening on, all right, I'm doing it on the color LCD and not on the projector. So let me do this on the projector instead, where this will become more obvious. So now you can actually see how it's modifying the contrast of the screen itself. Okay, so I'm squinting and you just got to kind of eyeball it. And if there's any color cast, you can use this tool. You can see that it's placing different color casts on the gray, trying to correct that particular thing. So just guessing this looks kind of right. And you have to do this for a lot of different shades of gray. And it becomes, your eyes get really tired because you're like this, sitting at your computer, and oh, it's such a pain. You can't open your eyes anymore. It's really terrible. Okay, we'll talk about this in just a second. But when you're profiling your monitor, this will just help you remove any additional color casts. And in fact, I did kind of a bad job because to me it looks like now this white well, I don't think this is a result of me messing with it, but it could have just been this way before. This just looks sort of yellow to me. It has sort of a yellow color cast, and it just doesn't look correct. Now, when you're doing profiling, there's a few things that you have to keep in mind. If you're using an LCD, this is probably the most difficult aspect of the profiling. If you're doing software profiling on an LCD, you have to be very careful that you are sitting at the exact height and looking at it in the exact way that you will normally be doing it. Because as I'm sure you've noticed, especially with laptops, when you are looking at something, and I don't know if I can do this safely, it actually will change the color cast depending on the angle that you're looking at the screen. And this is really bad. This is one of the reasons why LCDs are not necessarily the best for very good color management, because as soon as you start slouching because you get tired and you look at it at a different angle, the colors are different, and this is bad and this is annoying. So when you're really squinting at this and trying to get it right, I noticed what happened to me was that I was doing this and I changed how I was looking at the LCD ever so slightly, and then I looked at it and it looked horrible, and I'm like, oh damn it. So I had to go back and do it again and sit up straight and squint, and it was bad. It was bad. Okay. So anyway, make sure it is at the correct angle when you are doing this software profiling on your computer. Now, one of the things that I do want to mention is to continue this idea of color management software. So there's software that supports color management, and there's software that doesn't support color management. And the software that does support color management will read a file, and it will know that embedded somewhere inside of this file is a description of the color space. And so it knows just by reading this file, okay, this file should be read with sRGB, or this file should be read with Adobe RGB, and it will therefore know how to process and display those images on screen. But one of the most obvious pieces of software that traditionally are very, very, very bad about color management are web browsers. And just to give you an example, I have to use the other, let's see, this computer that is a Windows machine to be able to show you best. Oh, come on. Oh, good. Okay, so there's this website that's linked to off of the course webpage. And this guy loves to use funky text colors and lots of caps and all sorts of stuff. But if you read it, this actually has very, very good information about color management and color management software. Now, I want you to take a look. So I'm going to scroll down a little bit. So this is, keep in mind, a Windows machine running specifically Internet Explorer. And Internet Explorer, if you're not familiar, well, if you're using it, stop using it. It's terrible. It sucks. And this is just one reason why. If you take another class that I'm involved with, Computer Science E75, Building Dynamic Websites, you have to create websites that work across multiple browsers. And only then do you really get the feeling of the frustration that can exist between the differences in these browsers. So I'm going to try not to go into too long of a rant because this stuff is important. But Internet Explorer is bad, is very, very bad. And Firefox is very good, Safari is very good, and just download one of those and use them. All Internet Explorer is good for, I saw this quote somewhere online, all Internet Explorer is good for is downloading Firefox. And really that's very, very true. Okay, so on this web page, there are a variety of images, and these images are just used to show you, it's just meant to show you a variety of colors, a whole range of colors, and it's supposed to appear somewhat accurately. Now, in an image, we can either have an image that is tagged for a particular color space, which means that browser will then display those colors correctly, or we can actually strip the profile out of the image, so there is no color profile embedded into the image. That means that the web browser, or really any application that has to deal with color management, has to make an assumption about what those values for the colors mean, right? So it's as if it is getting a paint by numbers, and it is making a guess as to which paint applies to each number, versus a profile which will tell it, this paint applies to this number, this paint applies to this number. Okay, so we have a tagged and an untagged file. Now what's neat about this website is that this guy took those two files, there's a tagged file and an untagged file, and he laid them on top of each other, and by hovering your mouse over the image you can just quickly see both of them. So maybe I should switch back to how we do this properly really quick. So just to show you what this would look like on a web browser such as Firefox that can properly do it, we have a tagged RGB photo, and it looks like this. Then when I hover my mouse, it's going to remove the tag. It's going to be a file that has no tag, and you can see it looks different. Okay, so I'll do that again. Tagged, untagged, tagged, untagged. And you can see that there's this difference in color. The reason is that the browser for the untagged image has to guess, and so it's just going to apply probably sRGB with the monitor profile and just show you what it thinks those values should be based on that assumption. Okay, so showing a tagged image, then you can see that a color managed browser will show you that image properly. This looks better, this looks correct, and this is an example of what I was telling you before, how it's not necessarily a deal breaker because you can still see the image, but it's an annoyance. That color is not right compared to the tagged image. So color management, this is proof of concept of color management, but also this is proof that using a color managed browser is very important. And again, to make fun of Internet Explorer, okay, we have a tagged image right here, untagged. It looks exactly the freaking same, and it's annoying. This should be very different, but it's not. It is exactly the same. And so Internet Explorer fails as a color managed application, and it ignores whatever profile is embedded into the file, and it just applies whatever paints, so to speak, it thinks it needs to be applied to those numbers or to those values that are within the image. So I recommend that you take a look at this image or at this website and try to work through it, because it is actually really interesting, if a little bit dense, but you will get a better understanding for color management, why it is important, and how it can apply to applications and to web browsers itself. So here, so normally in an image, it would look normal, like this image of the baby and the children and all this other stuff that's up there. But just to give you a really crazy example of why color management is important, we can see this image. So here what he did was he actually created an image, and I should again show you what it should look like. He gives us an image that is properly tagged. So it might have a number, so this value for red, for example, but then there's some value within it that represents that red, but then there's this profile inside of this file that says, okay, this value actually represents this color, okay? So when we have a properly color managed application, we see these colors as we expect them. But if we remove this tag, if we remove that section within this file that tells us what color or what value should represent red, what color should represent cyan, then we see this mess. We see that what should be red is actually blue, what should be green is actually red. And this is just an extreme example, but it does show us why color management is important, because if we do not have the capability for a color managed application, then no matter what we do, we are going to see the incorrect colors on this web page. So again, this is over exaggerated, and the one at the very top, this is more correct to what we would actually see. Okay, now along with our discussion of color management, there's also something else that's very important that we have to talk about, and that is the fact that computers as well apply a tone curve to the display, to everything that is being displayed on screen. And this tone curve, we call it something completely different, and it's called a gamma curve. And so there's a value called gamma that basically defines how contrasty this image, or how contrasty a particular screen or a particular monitor is. Now you'll hear a variety of numbers. The most popular ones are these four up here, with the last two, 1.8 and 2.2, the most popular. Now, if you are doing anything remotely, let's see, if you are doing something really very professional, like you are going to send your files to a prepress, you're going to be working with Adobe RGB, you're going to be doing very professional level prints, then you might consider using Gamma 1.8. This was the default Gamma for Macintosh computers all the way up through and including OS 10.5. So those of you that know Macs probably know what I'm talking about. But in 10.6, and for all of the PCs out there today, we use a gamma value of 2.2. And I suspect that this is why what motivated this change to a gamma level of 2.2 was that pretty much everybody uses 2.2, and Apple said, okay, well, we got to try to make it a little bit easier for people to create images that look the same across different computers. And one of the things that a display calibrator will show you is the ability to pick a gamma. So right now I'm running 10.6, the latest version, and so you can see that by default it's targeting a gamma of 2.2 to display on the screen. But just to show you, just pay attention to this photo, and I'm going to slide the slider down to 1.8 so that you can see the difference in how it will appear. 1.8, do you see the difference? It's ever so slightly brighter because it's less contrasty. And so this, again, is exaggerated if you view it on a screen, but this actually was, before I understood all of this stuff, this was a huge source of confusion when I had a Mac and I was posting some photos online, and I thought they looked, nice, they had a good amount of contrast on them. Then when I viewed it on a friend's PC, and they looked overly contrasty. They were way too saturated, way too contrasty. This was the problem. I was running Gamma 1.8. My friend was running 2.2 because he's a Windows PC, and it was instantly, it had much more contrast, and it looked bad. It looked terrible. And I was like, oh, crap, maybe this is why nobody pays attention to my photos, because they all look really, really contrasty. All right, so I fixed that problem, and now people look at my photos. All right, so if you are running an older version of Mac OS, this is most pertinent to you. Change your Gamma to 2.2. If you're running a Windows PC, or if you're running the latest version of Mac OS, you're probably okay, but it's still probably good to check, because many PCs, especially older ones, tended to have even higher gammas because they realized that people really like that contrasty look, the really, the punchy, colorful look of a particular machine, and so they would sometimes up the gamma a little bit. Most likely, though, if you have a somewhat modern machine, you will have a gamma of 2.2 and be okay. But this is just as vital as the rest of it. And in fact, before I even come back here, and in fact, this will do a good job of showing you if you are, this same web page will do a good job of showing you if your monitor is profiled properly at a gamma of 2.2. So unless you really know what you're doing, I really recommend gamma 2.2. And so we can see that we have a tagged Apple RGB in this case, so it's slightly different, and it has a 1.8 gamma color space. So if we remove the tag, we would expect it to look the same in a 1.8 gamma monitor. But since there is a difference, we can see that there is a change. Because there is a difference in these tagged and untagged images, we can tell that we have a properly set gamma. So this is just a way of testing the gamma on your particular machine. So again, this is a pretty interesting way of learning about color management, and also a very real and practical hands-on way of doing it. But again, to do it, you really have to be running the latest version of Firefox, or even better, Safari. And the reason for that is this. So I'm just running a standard Firefox install. And so for a while, if you were running Firefox 3, they had color management support built in, but they didn't have it turned on. And you had to go to this confusing list of preferences to be able to do it. And so somewhere in here, I searched for color management mode. You have to change one of these to some value, and then it turns it on after you restart it, something like that. It's a big mess. Luckily, in the later versions, they've corrected that. It's at least on to some degree, but there's even still a different color management test where we can see that we have some color management on, but not everything. And this is opposed to Safari, which still maintains sort of the win in terms of proper color management. It is able to, it has it on by default and is able to show us the color that we expect. So if you like Firefox, that's fine, stick with it. But if you want a color managed browser that you don't have to futz with very much, then Safari might be the way to go in that respect. Okay, any questions on this stuff so far? Yes?
Dan, just quickly, any experience yet with Chrome or any of the other browsers?
Other browsers, let's see. I think I checked this once on Opera, and I think it was color managed. I don't remember. I don't actually remember enough about the other ones. I recommend going to that G. Ballard website, the one that has the pictures of the babies on it, and because that will, even just this first image will be able to tell you very quickly whether or not a web browser is color managed. Chrome also I don't actually know, because I have a PC, but I haven't downloaded it. I haven't tried it yet, so I don't know. I stick with the ones that I know would work, but you're more than welcome to test it out for yourself and see if it will work for you. Any other questions? Okay.